Hello, let's do the New York Times hard Sudoku for January 24th, 2025. If you are looking for yesterday's, I recorded it without sound and it ended up in a big long video that I posted saying, sorry, there wasn't any sound. Here's everything with no sound. So if you are looking for that, it's in there. I did add it to the Sudoku playlist, so it will appear in the playlist for the hard Sudokus. Anyway, let's get started on this puzzle. There is a link in the description if you'd like to try it yourself, and I'm going to get started right now. Okay, let's start with this 2, 5 here. So we have these two 5s looking in, putting a 5 in one of these two. This 2 looks in here, which is almost interesting. Almost, but not quite. All right, I don't see anything to do with 2s. All right, how about this 3, 7 then? So 3 actually looks in here along with this 3, putting a 3 in one of these two. That's going to point down with this 3, putting a 3 in one of these two cells. Anything else with 3? Not that I see. How about 7? We do have 2 7s. And this 7 looks up, so we can actually just place 7 in this box. Very nice. I'm going to adjust my keyboard here a little bit. All right, now these 2 7s look in here, placing this 7, not an 8, this 7. I am not seeing a good follow-up there other than this being filled, but we'll take care of that in a second. This column actually being down to 3. I want to finish this top band scan first, though. So that was the 7. Did I do the 5? Yeah. Did I do the 6? No. These 6s look in here, putting a 6 in one of these two. That points down with this 6, putting a 6 in one of these two. Oh, sorry, I missed this 6 here. That's why I use the red mark, so I don't miss obvious stuff, because this is intended as it's a live solve, but it's also a walkthrough. Anyway, that's a 6. These two 6s look in, this 6 looks down, placing this 6 here. Now these two 6s look up, this 6 looks in, putting the 6 there. Can I finish 6s? Unfortunately, no. Our final 6s are in this rectangle here. We have 1, 2, 3, 4, 5, 6, 7. So if you have 7 of a digit, either you can place the rest of the 2 or they end up in the rectangle like that. All right. Okay, so that was the 6. I'm glad I went back and checked that I did do the 6. I want to look at this column next because it is down to 3 digits. We have the 1, 2. We need 3, not 5. We need 3, 8, 9. These two cannot be 9. We have these two 9s looking in. In fact, if we want to, why not? We can mark the 9 while we're at it. That places the 9 in this column, only place for it in the column, leaving a pair behind, which is 3, 8, which is not resolved, although seems like it might be helpful. Okay, I'm going to come back to, this looks interesting, but I'm going to come back to that after I get down to it, because I do like to try to not miss anything, and which means going in order. So we've got, let's start with the, yeah, I guess we can start with the 8 here. The 6s are basically done, so we can ignore those. I am not seeing anything with the 8. All right, over here we have 2 and 9. Again, we're ignoring 6. Okay, so I have to keep reminding myself more than anything. I don't really see, oh, actually, looking down, the 2 actually puts a 2 in one of these two, which is going to point up along with this 2. This 2 looks in, placing this 2. Very nice. These 2s look in, putting a 2 in one of these two. All right, that was more progress than I thought we'd get. 2 and 7 already in this box, unfortunately. This formation can be very, very useful if you have something in this column or this row. Sorry, I didn't mean to do that. This column or this row that isn't already in the box. But unfortunately, we don't have that right now. Okay, we'll have to keep an eye on that, though. This column just got reduced to 2 digits. We need a 3, and we need a not 9. I missed it. We need a 5, 3 and 5. I don't think that's resolved. Oh, it is. Oh, the 5's there. Sorry. Sometimes I miss box digits. Anyway, so that's 3, that's 5. It seems like I'm not on my A game today, but that's all right. That means that's not 3, so the 3's here. So I don't know that there's more to see with 3s at the moment. I also got this 5. Sorry, not the 6. I got the 5. I mean, okay, so we don't even need this 5 to see that in this box the 5 is in one of these two. Now that joins the 2, giving us a hidden pair. So we know the 2 is in one of these two cells. We know the 5 is in one of these two cells. So working together, 1 will be 2, 1 will be 5, giving us a 2-5 pair, leaving a pair behind over here. Not the 2-5. It's going, and you can see it, or it can't be 2-5 just naturally. We need 3-7. So this 7 tells us that that's 3, that's 7. The 3 gives us the 8 and the 3. Nice. We finished kind of these two columns. Okay, so this is 2-5. I don't think we can do much with that right now. I am seeing this row down to 3 digits. I do kind of want to do that. It's 1-2-5. This can't be 1, this can't be 1, so the 1 ends up here. A scan of the boxes would have given me the same thing. This is 2-5. Let's finish this scan, this box scan, and then we'll move on to this bottom band. Sorry, this band scan. Band scan. Hard to say. Although this column is down to 3 digits also. I kind of want to look at that too. Getting distracted, but I mean, you find good stuff. 1, 4, 8 is what's left. The only thing I'm seeing, I see this 1 and 8 here. So this actually has to be 4 out of 1, 4, 8, leaving 1, 8 behind, which is not resolved. Okay. This being a 1, 8 tells me that over here, we have 4 digits left. So over here, there's going to be 2 digits limited to these 3 cells. So what's actually left? We need the 1, 3, 7, 8. So we know the 7 is over here, and also the 3 is up here. Okay. I'm looking at this 3 and 7 to help out. And so this is 1, 3, 8, and then this can't be 1 or 8, and it can't be 3. So this is actually a naked 7. Very nice. Leaving 1, 3, 8 here. Okay. And now up here we have kind of the same deal. We need a 1, 4, 8, 9. So the 4 and the 9 are up here. It's not a 9. So this is 1, 4, 8. All right, I think that's all I get out of that. I suppose that means this row is also 1, 4, 8, 9. 1, 4, 8. This can't be 8 or 9, so this is 1, 4 only. 4, 8, 9. Okay. This 1, 4 might be helpful. I'm not sure if the rest of this is. Okay, what did I just get? I just got the 7. So we should follow up on that. It puts a 7 in one of these two. It also reduces this row to 3 digits. So let's mark that up. We need a 2, 5, 9. I'm not seeing anything special about that, unfortunately. It might join this 2, 5 at some point, make a triple. Who knows? Okay. I think I need to make sure I did this band. That I finished this band. I know, I've been trying to finish this band forever. I think I have at this point. Okay, let's say I have. Let's move on to this band here. So I guess we should start with this box, which is down to 3 digits. We need a 2, 5, 9. That sounds familiar. It makes a 2, 5, 9 triple here. I was asked to explain this, and I actually have an opportunity to do. So I kind of quizzed you a couple days ago with a 1, 6. It was like it was a 1, 5, 6 triple, and I said 2 digits were the same. We have the same exact thing going on here, and I will explain it for those who weren't able to figure it out. So it's fundamentally what's important to understand is how this triple works. This is called a naked triple because you can nakedly see it just by penciling what's available in the cells. A hidden triple is only visible if you think about how 3 digits are equally restricted to the same 3 cells. So this is traditionally easy. This is traditionally considered easier to see because traditionally the solve involves marking every cell, which I definitely discourage. I think it's boring, and I think that it's lifeless. And it doesn't help you as much as you'd think. It helps certain things that I might miss, like naked singles, but you miss a lot of the hidden techniques, which are kind of the more fun ones to find, and you miss pointing and claiming, which can be very hard to see when you have it all marked up. Anyway, all that said, this is a naked triple. So what do I mean by that? How does a naked triple work? You might think that a triple requires all of these to be the same 3 digits, like 259, 259, 259. Now, what makes you say that the fact that we have this 9 over here and this can't be 9, what makes you say that that suddenly makes this weaker? How can that make it weaker? Eliminating digits can only make techniques stronger. It can never make them weaker because the logic is identical, except now you know further restrictions. And so with that in mind, let's talk about the way to think about naked triples without requiring thinking about all three cells being identical. So the way you want to think about this is this cell will in the solution be a 2, 5, or 9. That's what this marking means. If you look at the solution to the puzzle, you could, if you don't care, you can even like look at your own solve, or you can skip ahead to the end of the video, and you will see that this cell ends up a 2, 5, or 9. This cell ends up a 2, 5, or 9, and this cell ends up a 2 or 5. The other thing we know is that these have to be 3 different digits because they share a column, and Sudoku tells us they have to be 3 different digits. We cannot repeat digits in the column. So because they're all in the same column, they all have to be different digits. We tend to be very box-centric when we think about things and scanning and all that. That might be partially my fault, but a row and a column and a box are all fundamentally the same thing. We call them houses if we want to talk about them generically. And in a house, we have the digits 1 to 9 once each, meaning we do not repeat any. And so this, it doesn't matter what house you're talking about. In this case, we're talking about column 1. It is a house. And within that house, we need to place a different digit in all 3 of these cells. Now, if I didn't use the 2, 5, and 9 in some order in these 3 cells, how would I fill all 3 of them? Like, let's say I said, I don't feel like placing a 9 at all in these cells. Well, now I have 3 cells that are all competing over being 2, 5. Okay, well, that didn't work. Okay, well, what if I just say, well, they can't be 5s then? I don't feel like putting 5s into these cells. Well, now we have 3 cells competing over being 2, 9. And in fact, this one says, I better be the 2. And now both of these say they better be the 9. You have to have 3 different digits in order to fill 3 cells. And so the result of that is, since there are only, between these 3 cells, there are exactly 3 digits available in total, right? If you were to write down 259 and then update that with any new digits here and update that with any new digits here, you would find that 2, 5, and 9 are the only digits available. And so that means that 2, 5, and 9 must be used in all 3 of these cells, in the green cells. And so because that happened in column 1, the house is column 1, the rest of the house, which is affected by all 3 of these green cells, the rest of the house cannot be 2, 5, or 9. And that eliminates 2, 5, and 9 from all of these cells. And that's the power of the naked triple. Now, we have the same situation that we had last time, so I want to talk about that. In purple, I'm going to mark another 2, 5, 9 triple. Now, it's important that it's the same triple. So you can see in this box, these 3 cells will end up 2, 5, 9, and that's actually fairly obvious because all the other digits are already placed. But the important thing is that this is a 2, 5, 9 triple. Now, you may notice that these 2 cells are marked purple and green. Now, what I'm going to prove is that this cell here, whatever digit it is in the solution, this cell will be the same digit. So if this is a 2, this will be a 2. If this is a 5, this will be a 5. If this is a 9, this will be a 9. And the reason for that is because of these overlapping 2 cells here. We know that in some order, there will be a 2, 5, 9 placed in these cells, and in some order, there will be a 2, 5, 9 placed in these cells. Well, whatever this cell chooses, it's going to affect both triples. It's going to remove 2 from both of the triples, or a 5, whatever it chooses. If this chooses 2, 5, or 9, it's going to remove that digit from the triples. And so by the time these 2 are done getting filled with digits, there's only 1 digit in the triple left for both of these triples. And because the triples are identical digits, that means these 2 will be identical. So if this ends up 2, 5, these both have to end up 9. If this ends up 5, 2, these both have to end up 9. If this ends up, 5, 9, then these both have to end up 2, right? You can see it happening in real time. So that is why these 2 digits have to be the same. And we had the same situation, like I think it was like up here or something like this. I don't remember exactly how it was in the puzzle a couple days ago. All right. And I'm glad I have sound today because that took a while to explain, but I hope that was helpful for people who were struggling to understand that. And I did get a request to explain it in more detail, and I just found the opportunity to do that. Anyway, I have now completely derailed my solve, so I have to rebuild up my momentum, but that's okay. I think that was very important. So one thing that we can learn from this 2, 5, 9 triple is the 9's in one of these 2. We already have that marked, but it's kind of an interesting deduction. That means that these aren't 9, right? So at the most, they're 3 digits because there's 4 digits left in the row. So we need a 2, 3, 5. I am not seeing any restrictions on that, unfortunately. Now this is a 2, 3, 5 triple though. So one thing we learned is that the 3. So think about this triple, right? That I have in green. 2, 3, and 5 will end up in these 3 cells because if I don't put one of them in these 3 cells, I can't fill all 3 of them, and I must. So where's the 3 going to end up, though? We know it's not here, so the 3 is going to end up here, and that puts the 3 in one of these 2. That's one way to see that. You can also see it via the row, but the more ways you know how to see the same thing, the less likely you are to miss it. And that leaves a triple here, which you can see that we have the 2-5 pair here, which also told us there'd be a triple here. Lots of different ways to see the same thing. But we have 1, 2, 3. We need a 4, 7, 8. I'm going to mark that. And we see this 7, we see this 8. Okay. And I'm always on the lookout for things like, okay, this 4, 7, and 1, 4 have the potential to make a triple. This 4, 8, and 4, 8, 9 have a potential to make a triple. Things like that. 2, 3, 5, 9 could potentially be a quad, but we don't have it marked yet if it is there at all. The other thing is we did have this 2, 5, 9 triple here, so I do want to think about these 4 digits. We know because these aren't 6, with the 6 quarter mark up there is telling us that, that these will be down to 3 or fewer. But what are the digits left? So we have the 1. The 2 is in the 2, 5, 9 triple. We have the 3. Sorry, I should be looking at the column. We have the 3. So we don't have the 1, sorry. But these can't be 1. Oh, okay, so that simplifies things quite a bit. We need 1 and 6 still in these 4 cells, and these 2 can't be 1, 6. So the 1, 6 end up here, and that's a hidden pair. And that's going to leave a pair down here. If I can figure out what the last digits are. 4 and 8, it looks like. Okay. And of course, I'm always suspicious about 5 values. So that means there's a pair over here as well. So we need a 4 and 8. Okay. 1, 4. Okay. We're so close to having something going on here, but I don't think it is. So this is also 2, 5, 9 because 2, 5, 9 is left here. And so this can't be 2 or 9, so this ends up being our 5. Removing 5 from these 2, and notice it removes 5 from here as well. These are going to remain identical to each other, of course, as we proved. Sometimes that's useful. Most of the time, it's not actually useful to observe because it'll just naturally happen as you fill the puzzle. But it's still fun to think about things like that. And when you get into like more advanced Sudoku techniques, it can actually be very important to notice that two cells are going to be the same as each other. 1, 3, 4, 8. Neither of these can be 8. So these are from 1, 3, 4, and this can't be 1 or 3. So we have a naked single 4 there. That gives us the 8 and the 4 there. So that can't be 4, that can't be 4, that can't be 8. Okay. So now we've reduced 8 to one of these 2. I'm just looking at that triple, seeing that 8's in one of those 2. It doesn't really help that much. Let's see. Oh, this 4 looks down, giving us the 8, giving us the 9. That's not a 9, that's not an 8. 4, 7 pair. This can't be 9. That places the 9 in the box. This is 1, 4, 8. Looks like it could be any of them. This is also 1, 4, 8. Okay, this is 2 or 5. Can't be the 5 for the column. So that's our 2, that's our 5, that's 9. That's 9 and 2. So we know these are the same, right? That ends up 2 also. That's 5 and 9. So in our solution, these both ended up 2. Is our thing. 3, 5 pair. The 2 in this original triple, the 2 can't be in these 2. So now it's here, right? That's another way to think about it. So that's 5 and that's 2. We place now the 2 and the 6 and the 5 based on our corner marks. We get the 1 and the 6. We get the 8 here. That gives us the 1, 3, and 8. This is a 1, 4 pair. We get the 4 and the 8 here. We get the 1, 4, 1, 4, 8. Okay, this is finishing. 3, 5, 7, 4. We get the 7 here. This is 3, this is 1, and we're done. All right, I mean, 18 minutes, 25 seconds if you sit there and explain triples in great depth. So hopefully that was helpful for those who had questions about naked triples, or even a refresher on how to think about why triples work. I am very much a fan of understanding why the techniques work and being able to reconstruct them from scratch rather than memorizing patterns. Now, if you can still recognize patterns, like you need to use pattern recognition in your solves, but if you're not confident, like, does this actually make this a pattern? Do I remember the pattern or not? You can always go back to that base that you have, the strong core of understanding that you have. And you can go back and go, well, let me go back to first principles and see if I understand why this pattern works and see if this actually does work that way. And when you get into more advanced techniques, it becomes more and more important to really understand the concept rather than follow, recognizing patterns. Like it's really easy to say, well, if these two cells have the same 2 digits and they share a row, column, or box, and they eliminates those 2 digits from the rest of the row, column, box, and then not think about why, you just kind of do that by rote. But I think it's a lot more fun to understand what you're doing, and you can then do extensions of things, and you can expand things in your mind and understand how the puzzle's kind of fitting together better. All right, cool. Well, I hope this was helpful. I hope you enjoyed it. If you did, then why not leave a like, subscribe, and a kind comment below.